Okay, folks, at the end of the lecture, we're going to raffle off a book. In order to qualify for the raffle, you need a green ticket. I'm trying to see where. Trying to find our tickets. Hang on. Okay. Mark's got the ticket. So anybody who needs a green ticket, raise your hand. And Mark will help you out. Okay, while Mark is finishing the tickets, why don't we get started? Are we ready up in the booth? You all set? Okay, good. Good evening. My name is Alex Pavlak. I'm the program director for the local chapter here. I want to thank you all for coming to our lecture tonight, and I want to thank Johns Hopkins Applied Physics Laboratory for providing the facilities. Tonight we're going to hear about human systems engineering. Bill, Amy, and Kathy will be our speakers. I'd like to ask you to hold all of the questions until the end of the lecture. We target a 1-hour lecture, and we'll keep the last 5 minutes or so open for Q&A. The reason is we're going to be broadcasting live on YouTube, and we need to pass the microphone around so that people can hear the questions as well as the answers. So keep that in mind when you're asking questions. Anyway, without any further ado, why don't we get started? Bill, are you our first speaker?
Yes, I am. Oh, there it works too.
Outstanding. You're on.
Thank you. Hello, everyone. Thanks for coming. I am Bill Fitzpatrick. I work here at the lab at APL. Been here for about 11 years. I'm the human factors guy, or one of the human factors guys here. And yes, we do a lot of human factors engineering at the lab. Even though it's not well known for that, we've got about 20 human factors professionals right now. And we're going to talk about some of the things we work on, as well as kind of promote the class that we have within the systems engineering program. Integrating Humans and Technology is the class that I teach with Kathy, and she'll be talking here in a little bit. And we'll get right into it. So I work with a lot of systems engineers. You know, systems engineers are thick here at APL. They're all over the place. And they always ask me, they go like, Bill, you know, I like this human factor stuff. It's really cool, but how do I even write the requirement for this? It doesn't even seem like, how can you attach a number to that? How am I going to measure this? So they give me a hard time about it, but it is actually possible to do. You know, it's really not that difficult. It's systems engineering. Back in the day, I went to school at Embry-Riddle Aeronautical University, and I got a degree in human factors and systems. Cool program. And it was actually HSI. Human systems integration, but it was systems engineering, but your focus is a little bit different. That's all it is. You know, hardware, software, the human, that kind of thing. So we're just, it's the same thing except we're focused differently. So human factors requirements, they follow the same rules. Yeah, they have to be testable and simple, and you can't break them down anymore. All the same rules apply. Unfortunately, what the problem is when people present you a requirement, or what they think is a requirement, is really just a need statement. It's got to be easy. I want this guy, I want it to be usable, and I want him to, you know, be able to do it with ease, and it's want to be easy to learn. And so all these vague statements have to be broken down, and that's really the key to it. You have to take these statements and break them down into something that we can couch as a requirement, something that is measurable and actually a requirement. So one of the focus areas that we have in the class, Integrating Humans and Technologies, heavily leverages requirements writing. So it's part of the systems engineering program. So one of the first things we do is like, okay, we're going to assume that you know how to write a requirement by this time, but let's just go over it again. And then we give them templates and things like that. And here, this is how you write a requirement. So when you talk about how do you actually write these requirements, it's really not that difficult. It's just the same thing. Even for other engineering disciplines like hardware, sometimes, you know, people hand you vague requirements like, yeah, I want it to be super powerful. Like, thanks, you know, so those kinds of things that happen to all of us. Oh, all systems are judged at the human interface. This is a big one. Every time you produce a product, whether it's a weapon system or a rocket or a motorcycle or whatever you build, it's going to be judged at the human interface. People hand you a phone. Do you like your phone? Well, let's see how I can use it. And you judge it just like that, if I like it or not. Do you like your new car? Well, how does it operate? How does it feel? That's whether you like the car or not. Here's an example of a bad requirement written, I think it's probably one of the first requirements ever written, back in by the Army in 1907. It should be sufficiently simple in its construction and operation to permit an intelligent man to become proficient in its use within a reasonable length of time. That's what I'm talking about. People are always doing that to me. They're like, just build a system, this next version, just make sure it's not as, you know, at least as easy as the last one. Don't make it any worse. I'm like, so you see the quandary, and I know you guys go through it as well. Hey, do you got a baseline? Nope. Oh, well, that's going to be tough then. You know, making it better or not as worse as the last. So what you do is you break down these things. What is simple? What is intelligent? How proficient? What's a reasonable length of time? Now, these are things we can assign numbers to, and we can determine what a reasonable length of time is. How intelligent? You can group people, hate to do it, but you group people into percentiles of intelligence. You can do that with the height, their width, all kinds of things, but there's a general rule that you design for the 5th to 95th percentile. You know, so that can mean a lot of things. But you're going to eliminate Minute Bo, who's 7 foot tall, and you're going to eliminate my mom, who's like 4'10". So, but everyone else in between you can handle. Of course, for military things like that, the pool gets a little bit smaller and a little bit more under control, so you have a better chance of designing something that everyone can use. So why are we going to write these requirements? The human factors people, they're like, how are we going to affect change? And it's really not that difficult, but the key is getting involved in the systems engineering process. And I like this crowd because you're all systems engineers, so you're all like, yeah. But it's true. That's how you affect change. You influence the design and development of a system by being an integral part of it. You have to understand the systems engineering process, how requirements work, how all the little systems engineering principles and the development process works, and then fit yourself into it. This is a hilarious one. I don't know if it even applies, but I think it's funny. So I just put that in there for entertainment. Okay, I have to talk a little bit about HSI. As I said, back at Embry-Riddle, we were taught a course called Human Factors and Systems. And wouldn't you know it, that's what HSI is. Human Systems Integration. Class is called Integrating Humans and Technology. It's all really the same thing. But there are 7 pillars of HSI, a little bit of a guidance, a guide for human factors people on what we should be really thinking about. And it's fairly broad, but it's everything that the system is, or the person is involved with. Manpower, for example, is how many people are going to man this station. Personnel, who are these people? Do they have the right knowledge, skills, and abilities to sit that post or not? Training, of course, how is the system trained? And a lot of these things really make a big difference, especially training, because as people noticed, the logistics chain training, a lot of money is stuck into that. So if you shorten up this training cycle, it saves a lot of money. I've built systems or been involved in building systems that takes, guys 6 months to go to class. That's a lot of class. Sure, it's a specialized skill, but that's a lot of money, and they could be out doing other things. Environmental health and safety. Human factors engineering. Now this is kind of the pure, more of the pure human factors kind of stuff. Human factors, there's a lot of different definitions. I go with understanding the capabilities and limitations of the people that are using the system and taking that knowledge into developing or designing and developing that system. Human factors also has to do a lot with ergonomics. Human factors came out of aviation back in the 40s when people were shooting down their own planes and they couldn't figure out why they were shooting down their own planes. Well, it turns out, funny story, not really that funny, but on the side of the planes back in the day, the insignias on the side were very difficult to read. In fact, if they're moving at 500 miles an hour and they're about 10,000 feet in the air and you're zipping by them, really hard to tell. So that was one of the things, and they actually improved the symbology on the side of the plane so they were easier to identify. Survivability is a big one too. Obviously, ship gets hit, boom, are you going to make it or not? What's in place to prevent you from dying? Habitability, this is more of the quality of life thing. Submariners are awesome examples. They put them in a tube under the water, months on end, and they pop up and they wonder why they're strange. But that's a big thing. Quality of life is really important. If you're happy, if you're well fed, you can have rest, your performance is better. It's just that simple. You beat some guy down too often, his performance is gonna it's gonna wane. Okay, where do you do this within the systems engineering process? This is just a sample of a systems engineering process, but it kind of tells the story. As the system is developed, you're involved all the time. You're there at the beginning to really understand the needs and what they're trying to get to. You're doing human performance testing throughout. So you build a little bit, get feedback from the operators, maybe run a test, but that helps guide you building and designing a system that's correct. So going back, it's an iterative process, test it a little bit, go on, make some modifications, test it some more, make sure you're on the right track. And the operators and the users are more than happy to help you with this. In fact, there's a lot of folks that out there, a lot of sailors and soldiers and airmen that I wish they'd listen to me. I told these guys this 100 times, but they just won't listen to me. The reality is we find a list of 100 things wrong with the system. And then the budget comes. And guess what? but somebody's got to be held responsible for that. So who's that? That's the pilot. It's not the automation. So, and I'm being told to hurry up. Sorry, I'm a little windy. Uncertain mental models. For example, my favorite example is, you know how to think about a meat grinder. You see the meat grinder, you drop the meat in, you turn it, things move, gears, sausage comes out. You look at a computer. How does that work? You don't really see into the box. You can't see anything moving. You don't really understand it. Trust in automation versus over-reliance. So we have this great automation out there, but I'm not sure if it's going to work. Am I going to actually let that do something that might hurt me? And the other side of the coin is over-reliance. Yeah, it's got it. And then it fails. Improving the man-to-machine ratio is obviously a place we can use automation. It'll actually take the 3-to-1 ratio that's used for UAV piloting or UAV systems right now, and we can increase that to 3 to 100 if we wanted to. Cognitive and perceptual workload. Autonomous systems are built and they look like the old systems. There's no new interfaces out there yet. I'm working on it. But there's no new systems to handle this type of control, this mission level control. Engagement and workload, availability of proper metrics, functional and task allocation. This is a big one, this functional and task allocation. So it's really important that we don't just insert automation because we can. Insert it where it makes sense. Just because we can do it doesn't mean it's a good idea. For example, I don't got time for example, sorry. I'll talk to you guys later if you want an example. Now I want to talk to you about this because this is very important. Look at the interior. I think that's Corinthian leather. But this is my 2004 Toyota Sienna XLE Limited. It is for sale. Just so you know, it got about 150,000 miles on it. You might look good in it. And did you see the interior? It's nice. Heated seats. But one of the best things about this old 10-year-old vehicle is it has active cruise control, which is another form of automation. I don't know if you're familiar with active cruise control, but I'll tell you a little bit about it. It's just like your cruise control that you set, but it can see the cars in front of you and adjust accordingly. So you'll be spaced out, let's say you're 6 car lengths behind, it slows down, the car in front of you slows down, your car slows down. If it speeds up, it speeds up. It's just awesome. I just loved it when the first time I tried it. However, there's always these unintended consequences to this kind of stuff. So here's my story. So I'm driving down the road. It was down, actually it was down a 32 on 108 over here, and starts to get a little bit crowded. And let's say I'm going the speed limit. I'm not really not. So I got the cruise control set at 65 miles an hour, and then it starts getting congested. So what does my active cruise control do? Well, it slows it down a little bit, and that's no big deal. And it'll speed it up as well, up to your whatever you set the threshold, your 65 miles an hour. So as I'm driving along here, it all slows down and everything's fine. And I'm in the little tan car there. And then I get off on the off ramp. Guess what happens? It punches it, and I thought the tires were smoking on it. It was like, woo! And I'm like, I was shocked. I had no idea that it was going to happen. When I think about it, I'm like, makes perfectly good sense. There's nothing in front of you. I turn off, it can't see anything, so it's back to 65 miles an hour. But it's those little gotchas like that if you don't test every little piece of automation and all the possibilities, you'll end up with these surprises. Yeah. All right, that's it for me. Introducing Kathy Straub.
So I'm going to come at this from a slightly different direction than Bill. I come at it from cognitive science and psychology. So I'm the person that sits next to you on the airplane and you ask me about your friend's nephew's kid who at 17 still wets the bed kind of thing. And we also are the people who are confused with the people who are always watching everything that you do. But that's probably in fact because we are. Right? That's part of what we're doing as human systems engineers and cognitive scientists. Can we tune down just a little bit? So Bill gets questions from systems engineers. My dad's a systems engineer, so I get questions from him. And his question is, what is it that you really do that I paid for you to go to school for a really long time to do? Turns out that actually what he does, or what he did, and what I do are very similar. He was a systems engineer that worked at Ford, was responsible for handling the line, for doing the design of the entire line, for lost wax castings for engines. And his job was to make the system more efficient from the system level. It took us a long time to figure out that we did the same thing, because we called them different words and we have different processes, but essentially he was doing the same thing, observing how humans interacted with his line, trying to identify places where he could make it more efficient, and then working to engineer those efficiencies. The difference between him and me is that he could engineer those efficiencies and I can just draw them on paper, okay? So when he asks me what I do, I say I spend a lot of time thinking about how to effectively and efficiently observe what people are doing, how they're interacting with that technology, and documenting that in an evidence-driven way, the same way that Bill was talking about, so that we can provide those numbers back to you engineers who are numbers-driven for good reason, right? So we don't want to just say, we think it should work this way. We want to say, we've observed 50 people doing this, and 48 of them had this particular problem. We think this is something we might want to resolve. Some of us, I happen to be one of them, cross the border into that design space for interaction design. So those websites that you work with that make you mad at your bank, ATMs, some of your car interactions when you think to yourself, how hard is it to design a cup holder? We're some of the people that try to redesign those so that they fit the human size needs and the human size aspirations. Human systems engineering sometimes breaks itself into the people who just do the research and the people who do design. I think it's really important to do crossover and do both. And I think it's really important to be sketching all the time too. So while you're thinking about what people are doing, while you're taking notes of what they're having a hard time with, you're also sketching solutions and ideas. Those may not be your final ideas, but they're leading towards a better solution in the end, okay? So our second critical focus in the class that we teach together is really about the methods that psychologists and other people use to observe humans. So yeah, we're watching you all the time. One of the things I like to do when I travel is watch people go in and out of doors. Because you've probably hit those doors that the handle's the wrong way, and you run into the door because you realize it's a pull, but it really wants to push. And we watch how people resolve those problems. That probably now you probably want to go directly to your nearest human factors conference and watch all of us watching you, right? Because that's what we do. So we're really trying to figure out what the human or what the user experience is. One of the biggest challenges that we have today as human factors engineers, cognitive engineers, sometimes called usability people, is that people think a lot about the screen, but not a lot about other system level interfaces. So for some reason, the web has influenced us in a very bad way. There's a lot of web designers who've come up without a systems engineering background. And those people make us very nervous because they're worried about pretty in the browser, and we're worried about, it's not that you want to make a transfer, it's that you need to move money to help your kid pay his college rent, right? And you want to get to a soccer game on time. Your problem isn't the website. Your problem is a much bigger life-size problem. And the website is a small part of that large solution that you need to pursue. So when we're thinking about what the problem is, we want everyone to take a step up or a step back and think about the system level. So ironically, we're talking to you about being human systems engineers. I spend a lot of time with the people I teach trying to get them to understand that they have to start at that system level. Because often we don't. It's easy to look at a screen and complain about a screen, but it's that system level that we really want to think about. There's simple ways to do this. This is a do try this at home lecture, okay? The more you think about and interact with the people who are going to use your system, the more you'll understand about what they're going to do or not do. Yeah, you can use really formal statistics. Bill uses really important informal measures for some of the things that he does for pilots. Many of the things that I do on the industrial side are not things that people will die from. So we can use less formal methodologies. And in fact, one of the most important things you hear is that if you test one person, at least you've learned something. If you haven't watched anybody, all we know is that a really smart engineer can use this. The average bear is not you guys. Okay? So I spend a lot of time actually doing things like looking at websites that people need to apply for benefits on. Recently I did a state-by-state analysis of SNAP applications. You know SNAP, the now called, or what used to be called food stamps? You'd be amazed at how hard it is to make a simple form. You'd be amazed at how hard to make a simple form for people who are low literacy, who do things that you can't even imagine. We watched a woman who was trying to fill out the form make an error, and to correct her error, because she didn't know how to delete on a keyboard, she space-barred until the error went away and she couldn't see it. Imagine how the validation system handled that in the background. Okay? So we do think about things at the system level. This is actually an ecosystem drawing for a psychologist. It looks very different from yours. And what we're trying to figure out here is how people who are doing sales calls interact with the data they have from their company before they go in to meet a potential customer. So they have a laptop, they have a phone, they have all kinds of data that they get through their regular VPN system. When do they get it? When do they need it? How should we see it? As the owner of this business, when should I push information to you so that you know Dr. Smith has 2 kids and he just came back from Hawaii? And that personal connection, by the way, is very important if you're going to sell. Okay, so we want to give people the right information at the right time. This is a different kind of example, but it's the same question. Bill needs to give his pilots the right information at the right time so they select the right target and take the right shot. It's a different version of the same story. What we look at, particularly in these systems, is the barriers. So where people can't get done the things that they need to get done, or where they're blocked by the technology that they're offered. And we more importantly look at the workarounds. The workarounds are really the places where we have opportunity to re-engineer, where we have opportunity to potentially insert technology or take away technology, by the way, to make the process easier for the human from the human's perspective. It's those workarounds that they're best problems, and it's the engineering that works that solves problems that we have. One of the biggest things that we see as usability or human factors people is that there are a lot of engineering solutions to problems that don't really exist. This one, for instance. Okay, so one of the other things that we do with human systems engineering or cognitive engineering or usability is change behaviors. It's a behavioral change problem. Whenever you create an interface, whenever you create a system, you're trying to get me to do my behavior your way. And if you teach me by knowing what I can do and can't do, it's a much easier path than if you try to teach me to water ski and I'm a squirrel. You can teach a squirrel to water ski, evidence here, but it's really hard and it takes a whole lot of Fruit Loops. Okay? You can teach a human to do things that they are not prepared to do, like fill out a SNAP application, but sometimes it takes a lot of time and they miss benefits that they absolutely need because they can't fill out the form on their own. Today, as we transition to self-dependence in government, in our interactions with government, this becomes even more important. For us in this room, dealing with technology is irritating, but it's not a barrier. For many people in the world, being forced to deal with and interact with technology is a barrier to getting things they need to get done. So if you want to change my behavior, you have to be there when I want to change, right? You have to know what my whims are. Whoever was that put this candy bar thing on the aisle on the checkout in the Philadelphia Walmart or Walgreens or wherever we were, knew that this was a great spur of the moment. I'm waiting. I've got everything that I need. I got a couple extra bucks, and I'm going to walk right by there. You're going to make me wait there. You've got me. Okay? A lot of the things that we think about when we do interface design, particularly, and when we do design of things like this, the thing that's supposed to change my behavior and make me walk more or interact more, is to try to understand when those times are, when those moments are that I can actually take a moment, take a step back, and change that behavior in the direction you want me to go. So I'm going to give you an example here. I gave my dad some time, so I have to give my mom fair balance. My mom lives in Arizona, and I live sometimes in Arizona too. To me, solar power in Arizona is the obvious answer. For her, it wasn't so obvious. I tried everything. I tried the world. Don't you care about the universe? Your child? For years, I tried And then a couple years after I had my house powered, she saw my electric bill. And that was her tipping point. Okay? So everyone has their own moments that they tip. Okay, we got her there. The next thing I knew, she had an electric car. So she had, well, not quite electric, it's an MKZ. But so she has an MK, we got her, you got a picture of her there. And I said, well, are you really gonna try to save energy with this, or did you just like the car? I'm a Ford kid, so she got a good price, right? She liked it, she bought it because of the flowers. Okay, that may not appeal to all the gentlemen in the room. And the way that she learned to drive more efficiently, because she does get feedback, was not by reading the manual and finding out that if you partially brake at certain times, you change the energy load, blah, blah, blah. She learned to drive better because if she drives better, she gets more flowers. I will point out that I am not allowed to drive the car because I lose flowers. Now, if you think about Arizona, Arizona is very hot in the summer and you have to use your air conditioning. And what happens when you use your air conditioning? Your gas emissions go down, or your gas goes down. And there's no way around that. The engineers who built this car, although it has a temperature sensor, didn't build that in, right? They didn't think about that problem. So every summer she loses flowers. Every summer she loses interest. Quite frankly, that flower there was a killer. That's the one that's hardest to get, right? We had her, but then we lost her because she could no longer make progress to her goal. And now she's got this cool car with the flowers and I'm allowed to drive it because she doesn't care anymore. Okay? We had her behavior change significantly towards the direction we wanted it to go to, but because we hadn't thought through her limitations or the limitations of giving her positive feedback, we lost her. So that's just a fun example, but you can apply these same kinds of gamified examples. And gamification, by the way, is a hot new word. It is completely effective rebranding for motivational psychology, nothing more. Okay? We can apply these same kinds of things to really mundane environments like time cards. So time cards are the bane of my existence. I hate them. I run a business now, so I appreciate what they're for. I still hate them. We use one that every so often randomly reinforces you by saying things like, you're a genius. If your time card tells you you're a genius, you kind of have to smile, even if you think it's dumb, right? But it's kind of fun. And it kind of takes away that really terrible edge of the time cards that I suspect that you're used to, that you fill them out for 20 minutes after figuring out what your time code is, which by the number is a sequence of numbers and letters, not connected to anything like words, for instance. Okay? And then you get all the way done and it tells you you're wrong yet again for the 52nd week in a row. Right? It doesn't give you any increment of it. So these little things like knowing how to create a conversation between you and the technology, knowing when to reinforce me, understanding what my limits are and how to keep me moving towards that final goal turn out to be very important for human factors engineering. So that's a little bit the other side. I think I'm going to you're going to talk for a few minutes too about our program.
Amy, could you switch to another mic, please?
Okay, that works. Does this work? Oh, yeah, much better. Okay, I'm Amy Bays. I too work at APL. I am a pseudo human systems engineer, which means I haven't completed any human systems engineering training, but my background is actually in training. I know that's redundant, but I've gone through the Instructional Systems Design and Human Performance Improvement program at UMBC. So it is kind of funny that I'm involved in this program. But what I want to talk to you about today is the Johns Hopkins University Whiting School of Engineering Human Systems Engineering program. The Human Systems Engineering program was actually developed to elicit a culture change. As systems engineers, you guys are trained to do software, hardware, but not necessarily to include the human in that systems engineering design. So by developing this program, we're hoping to just increase awareness. Okay. If you've worked on DoD programs, you've probably heard the term HSI, Human Systems Integration. Okay, Human Systems Integration and Human Systems Engineering are basically the same thing. HSI, Human Systems Integration, breaks it down into 7 particular pillars, and actually Bill briefly went through those. The concept of, the concept of human systems integration is also that it's included in the systems engineering cycle from cradle to grave. So the considerations for the human should start at the inception of a project and follow it through to the end and actually loop back into the evaluation and the analysis and the redesign. These are the 7 pillars that, that Bill went through quickly, a little more detail. This is an illustration of just where human systems engineering fits into the systems engineering life cycle. So in the critical needs phase, we look at user identification, we build personas, we do needs analysis, and down in concept exploration, capability assessment, we do more analysis, cognitive task analysis, more detailed analysis, and we look at requirements. In solution validation, we build prototypes, we develop training, we consider the team, not just the individual user, but how the team works together. In solution implementation, we have usability testing, creating user guides, support information, and in deployment, we're actually doing the training and doing the maintaining and identifying improvements for the next cycle. Okay, so the Whiting School of Engineering has a system engineering program. I know that's not a surprise to any of you, but these are the 6 areas, concentration areas within the systems engineering program. And our human systems engineering, I believe, is the most recent. We started in 2012, is that right? In 2012, and we've gone through 1 cycle, 2 cycles of the 4 courses that we've developed. And we have actually in the back our first graduate, Lynn. So if you're interested in more information about the program, be encouraged to go back and talk to Lynn. She's very approachable. Or Bill or Kathy or myself. The purpose of this program is not to create human factors engineers, human systems engineer, cognitive scientists, anything like that. The purpose, as I said before, was just to heighten the awareness and give you some basic understanding of how to incorporate the human into the system. It's really to encourage you to find a human factors person and include them in the project team. These are the 4 courses that we offer right now. The Foundations of Human Systems Engineering is happening this term. We have that one both online and in the classroom. And this book that they're raffling off is the textbook for that particular course. It's taught by Maggie Beecher and Jen McNeely. And then Integrating Humans and Technology, you've met Bill and Kathy. They're the instructors for that class, and you guys go again in spring. And they're busy porting their class over to online too. And then we have 2 electives. We call them electives. They're really not electives. If you're doing the concentration, you have to do these also. But they're also available if you're just doing a systems engineering program. You can come in and do any of these as electives to the systems engineering program. The first one is social and organizational factors in human systems engineering, and it's taught by Nathan Boss and John Gersh. I don't know if any of you know either of them. It's a very interesting class that talks about the social aspect to including the human in the system. And I do a guest lecture there, so if you want to come and, just kidding. But I do actually do a guest lecture on training. So you get a broad spectrum of the human systems engineering, those 7 pillars. We try to give you a spectrum of those within these courses. The last one is methods in human systems performance management, or excuse me, measurement and analysis. And it's taught also by Maggie Beecher and Carlos Comparatori. And it talks about the different methods to collect data to measure the performances. Okay. As I said, in the spring, we have, these guys are on, and then we also have the HPM, the Human Performance Measurements class in the spring, and then in the fall, generally we run the foundations class and the social and organizational factors class. Gradually, we're porting them over to online. So if you're an online person, how many, I'm just curious, this is just my training site. How many of you have taken online courses? How many of you like taking online courses? Okay, I see a couple of people doing this. Yeah, I was just curious. It's kind of one of my little pet peeves. I'm not an online person. I just don't learn that way. But so if there are any questions, I'm available, and Bill and Kathy are. Yes. Oh, do you have the microphone? Oh.
Test.
Thank you, Amy. Let's have a round of applause for Amy, Bill, and Kathy. And now we'll take questions and answers from the audience.
Yeah, I have a couple of questions. Well, a few for each speaker, but for you.
Okay.
So the MEF modeling disciplines, you know, feedback control, biostatistics, for data gathering and modeling, are you doing something in that area, or pick that up, or they take that track? But they did a lot of this way back in the 60s, and the and feedback control and the human in the interface.
I believe some of the classes touch on that, on the feedback control, but in terms of modeling, I don't know. I know.
So we do quite a bit of modeling. Some of that modeling, that biometric feedback and the feedback control, that is something we. Am I out? Okay. That is so. That's they touch on it in that class, but no, we don't do that. In fact, we usually hand that off to other folks to do. Right now, especially with the biometric type stuff, it's a big gathering of information, and the feedback loop control we actually got. You know, the video I showed. The feedback loop control actually came out of our RED program over here, our research and engineering folks. They used that feedback loop that was actually that drove the prosthetic limb. So when somebody was a quadriplegic, they could look at something and then they could move the robotic limb to it. And I'm like, huh. I sat there and thought about it for a while. And we actually used that exact feedback loop in this system where we're taking biometric sensor information and then feeding it into a control system.
Dr. Harshbarger's DARPA project.
Right.
Yeah.
Correct.
Yeah,
Correct.
we heard him. IEEE had him 3 times.
Oh yeah, they're pretty famous. They made 60 Minutes and stuff like that. But I just took that technology. I'm like, this is amazing. So you could take something off of the human and make a control out of it. I'm like, oh my gosh. You know, it was kind of one of the epiphanies for me.
So do you look at, like way back, they were monitoring the old example, the X15 heart rate. That was around 1961 or so. We saw they were confidential reports at the time. But that was one of the things they were monitoring. And then ARINC started to monitor, for their interface for HF communications about 14 years ago, flights coming into the continents. They were looking at, the displays and how the humans interact with the displays. So they were monitoring some of the operator parameters
Right.
also.
Right. Another example for you, and it happened at APL, one of the beginnings of all this biometric stuff was the lie detector. So back in the Cold War, when they busted the spy, they wanted to know if he was lying. And they put, well, we still use it when we get our clearance, that stuff. And I'm not a big fan of that because I know how it all works. And it's like, really, I don't think so. But I still go through it. But that was one of the initial projects here. And this stuff goes back, like you said, 60s, 50s, when they in the beginning.
Well, I'll talk to you later.
All right.
Let someone else have.
Any other questions?
Of course, he's way over there, right?
So one of the current popular design philosophies is design thinking. How do you feel design thinking fits into like human systems or usability or that kind of thing?
Oh my gosh, I gotta feel this one. No, I think design thinking is a wonderful thing. One of the things that I don't like about design thinking is it's just relabeled human factors. A lot of the tools and the processes they use in design thinking, card sorting and hanging up cards and brainstorming and focus groups, that's all old hat to us. We've been doing that. That's how we do our interviews. That's how we get our information to begin with. Super valuable. I'm glad there's a lot of interest in it because it's the same thing, just labeled differently. I was a little disappointed when the lab started because I'm like, don't you know you got human factors people here that do that? But regardless, it's a good positive move towards design. I'm glad that a lot of the sponsors like it. They picked up the new buzzword and they're like running with it, but it's really the same thing. So
one of the other big pluses about it is that it gets the user involved from the get-go, as opposed to waiting till we've designed something and we throw it over the fence and then see if it works and see if they like it and see if it actually answers their problem.
But I'll just add to this, the thing that probably makes us a little bit nervous about it is there is a distinct design methodology behind that that's evidence-based. And when things get popularized in that way, we often lose the scientific basis behind the thinking, and it becomes a lot of people offering their opinions about how things should work and their experiences with their own refrigerator or their own cruise control. And then we don't have that 5 to 95% data. We have the designers thinking about how the designers should portray it, and what we have then is a design for the designers. So we complain about engineers designing for engineers, but programs like that worry us because we end up with designers designing for designers. If that makes any sense. But we're here, ask us if you want to know the science behind it.
Any other questions? Okay, right before we take this last question, just raise your hand if you haven't gotten a green ticket yet. Mark will come around.
Okay, either the second speaker or the first speaker. When you look at displays, we've had a lot of different operating systems from MicroPatch, Microsoft, and there's a lot of issue with interaction when they don't do something, whoever they get to design them, whether they're in India, whatever, and they're going back to some of the older interfaces for Windows 10. So do you also evaluate, the usability on displays?
You bet. Yeah, that's actually sort of where the hot button is in the industry right now. And that's another place where it's quite, I don't want to say easy. It's easy to apply best practices, but it's better to watch the target users doing the target tasks in that environment. So often what will happen is people will test it themselves and create a list of their own mistakes and problems, where if you let us play, we'll come in, we'll do similar things, but we're going to watch, if, for instance, at a bank interaction, we're going to watch people doing their banking. If it's designed for a pilot, we want to see a pilot doing it. We don't want to see a psychologist doing it. And we don't want to see an engineer necessarily doing it because the engineers designed it. They know too much about how it works. So things that are intuitive to them because they were in the design process may not be intuitive to the end users, and we won't see that until we deploy. So that part of asking people early and often to show you how they would do this. That's our key question. Show me how. Show me how. Not tell me how. Not I'm going to show you how it would work, but rather show me how you would do whatever the task is that you need to do. I get to sit quietly, which is often quite painful because I've designed it and I've got a dog in the hunt, right? So I have to sit back and watch and take notes on where people stumble and then go back and redesign it. One of the things that we see now, in addition to design thinking, is this rapid iterative design. I don't have to mock up the full capability. I do a lot of drawing and sketching. You can do it on the back of your O's ticket because you got extras now, right? And so,
Wow.
and
Out of
so,
left field.
I don't even know her, man.
and so, it doesn't have to be a formal interaction design. It doesn't have to be a formal capability, right? So you can do these in very lo-fi environments. You do them early, you make your changes early. That saves a lot in the design process. So just as Bill was talking about saving money in the training process, you can save money in the capabilities building process by knowing what people will know about the interaction ahead of time.
And just
Years ago, they used to hold it. Looking at other attributes back in the 60s, we're talking about electromagnetic interference, but we evaluated communication systems, or ADC. They had articulation score and articulation index. That was something, I guess they still do that.
Yeah.
At least the hearing audiologists do that.
Yeah, so this is the part of that, you know, my dad was a systems engineer and he did the same kinds of things and thinks in similar ways. We've labeled them a little bit differently because I'm trained as a psychologist, not as an engineer. But ultimately, we're having those same questions about how to make the system be more efficient, in our case, from a user, or including the user in the design. And oftentimes, engineers have that sensibility without having to, you know, have it pointed out.
And one of the things from my background in training is that the training domain is actually trying to move away from training, which sounds kind of strange. We're putting ourselves out of work, but it's called human performance technology. In other words, they don't look at, you know, how am I going to train somebody to use the system? They look at how the system's designed and how can I design the system so that I don't have to train people to use it. It's like, how many of you have iPhones or iPads? How many of you read the user guide when you got it? Is there a user guide? No. So you learn how to use the thing because it's very intuitive. It's very well designed. Now, how many of you know how to take a screen capture on your iPhone? Okay, how do you know that? Why do you know that?
Because that's part of my job.
That's part of your job. Okay, how did you learn that? How about that?
Because somebody else I know told me how to do it.
Right, yeah. I mean, it has become a very cultural peer-to-peer learning way of learning, but you know, you can, once you use your iPhone, then you can go on your iPhone and say, okay, how do I do, and it'll teach you how to do it. But you have this base knowledge because of the quality of the design.
And so just to add to what Bill had said and combine with that earlier, one of the things we ask people to do in our class actually is take pictures of things that are broken and complain. And over the course of the semester, you have to change your complaints from just sheer complaint catharsis type complaints to human factors requirements, to how to fix it and make it right.
One last question.
Has one of the big things in the news right now is wearable technology and how we're all with our watches and our glasses. Has that really changed how people are now, the respectability of human factors engineering? I mean, you've been doing it for so long, probably with the soldiers and with the pilots and the sailors. How is this going to impact the field? Is it going to increase it? Is it going to become more? Is it going to come more to the forefront and getting users more interested, or people more interested in the whole design up front?
I think so, and I hope so. The wearable technology, the mobile technology, of course, is huge. Everyone's got one. Everyone's got one in their pocket. And one of the big things that we get out of the sailors or the warfighters in general is, well, for example, I'm on a ship, I'm doing this thing, and sitting at the computer workstation and they look at the graphics and it's all green phosphorus and they're like, look at this crappy trackball. They're like, I got an Xbox underneath my bunk that can kick this thing's butt. So technology is moving along. As far as wearable computing, a lot of people are using it. We're starting to transfer a lot of control systems, SA systems onto the phone. Back when iPads or, what's the original iPod? When the iPods came out, we noticed that the seals all had them and they loaded up all their maps on them. Now they're not digging out a map, looking at, there it is. Excuse me. So those things are starting to become expectations out of the users now. They're going like, well, I've got all this technology. I got the space shuttle computing power in my hand right now. Why can't you just give it to me here? So that's going to become a big deal. The Google Glass thing, well, it's got all kinds of other issues, but that's also going to come into play.
Actually, just this morning, Bill, there was a report about Google Glass, and I was going to follow up your wearables comment about and question that an individual apparently had been using it sort of day in, day out for like 12 hours a day, and then has actually gone into some sort of therapeutic state because he has addiction to his Google Glass.
Wow.
Like he will literally have he has a physical addiction now to the Google Glass.
Well, that's unexpected.
It was reported this morning on like CNBC or something. So there's like some reports that there's like something about the closeness to it.
You sit and think about, Kathy's got a great, the psychological approach to that. If somebody walks up to you wearing a pair of Google glasses, I will leave. I'm not even talking to you. I don't want to be on camera. I don't want to be in some computer. Who are you? Did you ask my permission? Imagine if everybody ran around with those on. Those make me uncomfortable. That's just me, but I think a lot of people share that feeling. Where's that line we're going to draw? Being the, this, what do they call that? Some kind of state. Personal space. Yeah, well, personal space. It's the privacy. The ACLU is going to lose their mind when that stuff really hits. So there's there's good things and bad things about it. I mean, they could be an enabler, but we got to be careful with all the technologies we go, put out there, all the wearables. What are the impacts that we don't understand? Just like automation, what are the impacts that we're not understanding? So we just have to be careful.
It's what I call the Jurassic Park syndrome. Just because we can doesn't necessarily mean we should.
That's a good example with glass too, right? Think about how the iPhone was an interruptive technology and everybody has something like that now, and think about how many people are waiting to get their glass. Not many, because it's a cool solution, but it doesn't really have a problem associated with it yet. So we're more concerned about the privacy issues. Whereas your iPhone, if you're away from your iPhone for 24 hours, then people do start to shake, and we understand that intrinsically.
Hey, I told you that in privacy. Okay.
Hey, I'm sorry.
Well, one of the great applications for a Google Glass, well, it was a head-mounted display, is for a maintenance person. So you're going in there and let's say you open up not the hood, but some panel on a F-16 and you're crawling in there and you're trying to reach around. Boom, the schematics pop up right there. So you actually can see the schematic while you're reaching your hand in. I thought that was really cool because your hands are free. You can see what's going on. You don't have to drop your tools or anything like that to see where you are. So
I think we'll end it right there, but thank you very much, folks. Appreciate your taking the time to speak with us tonight. Before we do our parting gifts here, we're going to give away a great book. I mean, this is a thick book, one of the thickest we've given away this year. The Introduction to Humans and Engineered Systems by Remington, Boehm Davis, and Folk. So please get your green ticket out. And Bill, why don't you come on up over here and
I don't have a green ticket.
Do the number pick for us.
All right.
I knew there would be some kind of.
Do I read it?
Read it out.
Can you hold that for me over there? No, I got it.
I'm going to go.
Two. It is 225102. 102. We got a winner.
Right, come on.
I'll hold this out to verify.
We usually take a photo with our winner, so if you want to steal your badge.
Oh.
Kid stays in the film, right? All right, good job, everybody. Pat, give us the count off.
How do I look?
Great.
Yeah.
Congratulations. Mark will tell you we need a book report.
Yeah. No, good.
We don't usually do it in this manner, but what I want to do is I'll present you all with your certificates and your coffee mugs. Well, they're not really coffee mugs. They're actually caffeine delivery systems. Well, Kent, where are you? Started. If you drank this much whiskey, you wouldn't care how much you paid for this mug. So we should actually sell them for $50 and serve them with whiskey, right? We could. We'd get in trouble though. So thank you very much. Here's your Chesapeake chapter, the logo for the 20th anniversary, and it's a caffeine delivery system. And everyone, let's get a great round of applause, and we'll.
Ooh. Oh.
Again, we haven't done more than one speaker here.
Oh, this is you, Kath.
I don't think we've ever done one. Didn't forget you.
All right. Oh, I need my watch. Ooh, ooh, ooh.
Get in tight, 'cause I don't know what kind of camera this is.
All right.